Welcome to ETM-130 with Paul Prate and Zachary Schiebel. This is our practical test 3. We were given this diagram here, and we were asked to draw an I/O diagram, input-output diagram, actually make the circuit, put it on the PLC, download it, interface the variable speed drive with it, and go online and test it out. So this is what we were given. We have 6 seconds on the acceleration, 15 seconds cruise time, and 6 seconds on the deceleration. The rest of this math is just if it was proportional with the speed going through like the graph shows, but we just had to do what's in the green. This is our I/O diagram. So the stop button is the first input, data 0. Start is data 1, run is data 2, and in the program they're listed as advanced HMI digital inputs. They're just represented, which are just representing what would be normally actual push buttons. Our output is our local 3 chip 0, channel 0 data, and that's hooked up to the VFD. That's going to be pretty much our only output other than the internal start in the program. So our actual program here is the proportional control program, which just starts off with our push button situation, the 0 and the 1, the stop and the start. When you press start, it locks in the start OK, which will in turn pretty much start the master control relay, which after that, when you press the push button 2 for run, that'll actually start the motion control here, which goes through all of the math for each of the control zones. So you have the start of the subroutine, and it starts the zone counter preset to 4 automatically. You have the zone timer when it's done will alternate between acceleration, deceleration, off time, and cruise time. That's what that is. We have our, also when it's done, it'll control this one-shot bit, which will run this line one time, which is the actual count-up counter that controls which control zone you're on, which is 1 through 4. And then this one is the reset, that when that goes is when this hits 4, then it'll go through and reset it back to 1, which will turn on the off time. The line here shows that if the zone counter is equal to 0 or equal to 1, then it will turn it on off time, which is how long it'll be off before it starts accelerating, and that will move the 0 to the calculated speed, which will in turn make it completely stopped. The second one is going to be the acceleration time, which is set to 6 seconds or 6,000 milliseconds, and that is pretty much calculated speed is the command speed divided by the max speed times the accumulated time, so that when time increases, the speed will proportionally increase to get to that command speed value. Command zone 2 is going to be the cruise time, so pretty much which once it gets to here, it's going to be preset to the actual command speed, and it's set to 15,000 milliseconds or 15 seconds like we were asked to do in the program. And that will also move the whatever the command speed is set at to the actual calculated speed, so that's what the motor will run after the 15 seconds. And then the zone counter 3 is the decel, which is the speed reduction, which is the command speed divided by the max time times the accumulated time, and then the command speed minus the speed reduction is the calculated speed, and that will run at 6,000 milliseconds or 6 seconds as well. And this is the math showing that I just explained there. And then I'll return to the main subroutine. We have our scales input, which is our RPM calculation at 1740 divided by 10,000, which is the track bar speed, would be 17.174 times the track bar speed will give us our command speed to increment at. And then we have our scales output, which is the max out track bar output divided by the RPM. 1740 gives us the output slope, and the output slope times current speed will give us the actual speed output, which will increase or decrease to that value as the speed changes on the track bar. So,
all right, so basically how our stuff works is we've got this advanced HMI input here, and this is getting connected directly to our PLC. And as you can see, as I drag this track bar down, our motor over here is going to slow down. So I'm going to set this to about half speed. It's going to take 6 seconds to get to where it's at. Now I'm going to ramp it all the way up. And then it should slow down pretty soon, because we have 15-second cruise time. And then we have a 6-second decel time, so it takes 6 seconds to decel. And then we have 6 seconds for it to get up to the 10,000, which is our 10 volts or full speed on the motor. And then it's going to sit here for 15. And then once that is done, it will take 6 seconds to decel. And then it'll wait a little bit and then go back up. So that's pretty much how it works. And then we can adjust the speed from here. And that's just going to vary the voltage that's coming out of our Allen Bradley VFD that's over there. So that's pretty much how it works. Just how the I/O diagram described it as. So that's how it works. Thank you for watching.